Hello. I can hear. I hope you can hear me. Yeah. So that's it. There's going to be some delay. Anyway, let's carry on. So, so earlier I was working on Leetcode problem, and I didn't get to wrap it up properly. So this was a problem that I was working on my previous video. I mostly spend my time tinkering with the settings and the live stream setup. So there was a lot of time spent on that. And then I spent quite a bit of time looking into uh, this problem, and this is the code I came up with. It is passing the Leetcode submission. However, the code is pretty different from the solutions that have been proposed and suggested. Not too much, but there are some things that I could use. For instance, I saw people are using instead of accounting for whether each string is shorter or longer than the other string, all they do is just add zeros in front, leading zeros in front of strings that are shorter to the maximum length. So that way they solve this problem. And then for this, for starting from the last number, since the two strings are equal in size, they start from n minus 1 and then progressively take a step backward. And since two strings are equal, that's something that you could have optimized. Another thing that I noticed that they were doing was, some others were doing, instead of considering each character string end to end, what you could do is convert them to an integer and then add them together, and then do a modulo 2, and if it's equal to 0, then you can convert that to a binary, and if it's equals to 1, you can convert that to binary. So you can try that. Apparently that was an interesting one. You can add up and then do a modulo to get the numbers instead of writing all these rules by hand. Excuse me. So those are different, and even here, if we account for the string length, we would have only one function, and a lot of these would have been simplified. Yeah, there are a lot of solutions, but most of them are very similar to each other. Mine is pretty weird because I did not convert them to numbers. A lot of them convert them to numbers and then do a modulo and then divide by 2 to calculate the carry forward, which would simplify the code that we have here, but the idea is kind of the same. And yeah, that was, and then the zero filling, that was interesting. I'm sorry, my voice is breaking. Sorry about that. Oh, it's still breaking. I don't know what I did. Just bear with me. So anyway, I don't expect this to be watched by audience, by a huge audience. Sorry, this is bothering me. Give me a second. And I forgot to turn off the notification on my phone that's streaming this. All right. Sorry about that. And I think my voice is gone for some reason. But let's proceed with the problem. So this is a problem that I've not seen before. But before that, actually, what? Let's do a quick recap of what we are doing here. So uh, the the reason for me to stream these um, is to get good at my goal for doing this is to get good at Leetcodes and be able to explain my thought process as I'm doing it. So I'm not sure how beneficial it will be for others who are watching this, but this is just to make myself more comfortable um, practicing Leetcode problems and also explaining myself. I could have just recorded and posted, but then there would be no accountability in that, and this way, by streaming it, maybe I could notice my progress over time, and yeah, why not? It's free, and who knows? Probably it's a good data set. So the format that I had in mind was just spend fixed amount of minutes to look at a code and give and attempt it, and later on, after that number of seconds, move on to looking at solutions and understanding what you're doing wrong and what the solutions that are proposed by other is doing right. Okay, so oh no, I've been talking to myself without showing you the code. You've been staring at my face for this whole time. So this was what I was referring to earlier. Oh man, this is the code that I worked on previously, and then this is the part that could have been simplified. Instead of just considering these characters as strings, we could convert them to 1 and zeros and add them up, and then do a modulo on it, so that you can do that numerically instead of doing writing everything out explicitly as I've done here. Another thing that I was saying was, oh man, my voice is really breaking. Okay, another thing that I could do is we can zero pad the shortest string to the maximum length, and then we don't have to do the reversing probably would take a bit of time and a bit of complexity as well. And here with that, we could just start from n-1 and go all the way to n-1 because it will stop at 0. It's exclusive. So, and then you can remove you can simplify and refactor a lot of this code. Excuse me. Okay, let's move on. So, and what I was telling you just now was, I'm just doing this for my own sake, and I don't expect anyone to find any value in it. This is mostly for me. But if you do find it interesting, do subscribe. I don't know why I say that. I'm saying that, but I don't get paid to do any of this. This is mostly for my personal record and stuff. Okay, so this is one of the famous climbing stairs problem I've heard, getting referred in a lot of Reddit posts. And we are starting from lists of easy problems and then slowly progressing to the harder ones. So just to get myself comfortable and get in the mindset of writing algorithms. I mean, I've been writing code for a while, but algorithms require especially Leetcode or style or algorithmic problem solving style, um, requires a bit of exercise, just like maths. Even though you know how things work, you can read about it, but then when it comes to implementing and thinking about them, you actually need some practice, and that's where I'm here. So let's start. So the format is going to be me looking at this for a few seconds, and then try attempting it, and later on moving to the solution and see what I've done and what, just like how we did the comparison here, looking at a solution. Hey, you did this part right, but you know what, you could have done this better, and you actually don't need this, you could optimize this way, and and so on and so forth. So okay, let's look at this problem. I heard about it, but I don't know what it is actually about. If it's really difficult, I don't want to waste time. I'm probably going to skip to the next one. Okay. So you're climbing a staircase. It takes n steps to reach the top. Okay. Each time you either climb 1 or 2 steps. In how many distinct ways can you climb to the top? How many distinct ways? So when I hear this phrase, how many distinct ways, what I can think of is combinatorics. Combinatorics and steps. So 2 steps, 1 plus 1, 2 steps. 2, the 3 is a climb, 1, 2 plus 2. Okay. So how would I do this? Recursion is what comes to my mind. Okay, let's add result. So this is going to be a recursion or dynamic problem. So def is recurse, and then the input will be n. You don't need to input, you can just get it from the, no, actually you need input. I thought we could just use a global variable, but that doesn't make any sense. So, and then for each n, you could do how many steps? You could do, so at each, so this, okay, I think this is the dynamic programming. Yeah, this is the dynamic programming problem. Because at any given time you could take few steps, and then once you took the steps, what do? You undo those steps and then start from where you left off before that. So this is gonna be interesting. Occurs, and then you can say step. So okay, we need to come up with a base case. If n equals to 1, return 1. So one of the perks of you watching this video is you get to get the feel of how dumb I am. Yeah, I've not done competitive programming for a while, or competitive programming style stuff for a while, so I'm humiliated by this, but it's okay. It's the mentality that matters. I don't know, but I will learn, hopefully. Okay. So you could actually see a tree forming here. So at the first step, you will take 1 step, or you'll take 2 steps, and then we'll take one step, and then this one step branches in two states. Either take one step or two step, and then once that you can only take one step. There's a possibility. Based on the possibility, you can only take that step. Okay, so if do something and then recurse n minus 1 step equals to 1. Okay, I'm completely not sure what I'm doing. Recurse n minus 2 steps. Okay, what you can do is just if n equals to step, then return what? Return 1? Yes. If n equals to step, just return 1. Okay, so you do recurse. You're not changing the state, are you? We're supposed to do n minus step. Okay, n minus step, n minus step. Okay, so we're here looking for a number, so we can just add to the result, I guess. Result plus 1 recurse. Okay, this is what I meant when I said you need practice. This is dynamic programming, but I don't have enough practice in this. Give me a second. Okay. I just checked my YouTube streaming. If it's everything alright, it seems alright. Results, recurse, step. This is a simple problem. Why is it taking me so long? I think it's going to rain. Each time you can climb either 1 or 2 steps over the page, you have to take 2 positions and will reduce after every iteration. And then this return. How are we going to start this? Okay, now I don't need this step. I think it's just recurse then step is not step, it's just 1 or 2. -2 will get few combinations, -1 will get few combinations from where you are. And how you backtrack? You're not changing the number, so you can easily backtrack. If it's a list, then you probably need to amend or change the list and then backtrack. Since it's just a number that you're passing around, you can just, so if n equals to 1 or 2, how would you know where to stop? You're fucked. I think you need to stop. Holy shit. Okay, so we actually need to do a base case. If f minus 1 is more than 0, then you do that. If n minus 2 more than 0, you can pursue that path. And all the way up till, so let's say if you got base case 2 n equal to 2, and then what would be the base case here? The base case is when you specify the step equal to 1 and step equals to 2. If number n equals to step, you just return 1. There's only one way you could achieve that. And if it's 2 and equals to step is not defined, okay, step equals to none if step and n equals to step, return 1. Okay, if n minus, so when it's n equals 2, n minus 1 would be 1. 1 is more than 0, so it recurs. And then n minus 1 would be 2 minus 1, which is 1. Step 1, 1 equals to 1, it will return 1, and then you add that. And then for this one it's the same, n minus 2 equals to 0. 2 n equals to 2 minus 2 is 0. More than or equals to 0. So more than or equals to 0, would that work? Okay, so more than equals to 0, and then minus and add it to the result, and then you just return the result. I don't think this is right, but let's try. Yeah. 2 equal to 0, because I'm not calling this damn thing. Okay. So because n equals to that and submit run code. Alright, result referenced before assignment. Okay, just turn 1. Oh, okay, it should return something. Return. Okay, so we start from scratch and just return. Run. Oh no. What's happening? Why is this one? It's raining. Told you. Okay, so what's happening here? What the hell is happening here? Okay, let's see if we can improve this font size. That's the max. Okay, thank you. The result equals 0, return 1, and then wait, what? Return 1. Okay, that's the base case, so it returns 1. Oh no, return step, bro. Yes, you have to do that. Oh no. So step 1, step 2. Right. I don't know why it's not working. Okay, let's trace through these two. Okay, we pass 2 through right over here. And then step equals to none, so we don't do that. And 2 minus 1 equals to 1 more than 0, yes, so it'll do another recursion. 1 1 1 1 equals to step, so it'll return, so it plus. No. Okay, so alright, I got the base case wrong. Fuck. I got the base case wrong. So if you notice, the base case is when n equals to 0. How could I not notice this? Okay. If n equals to step. If n equals to step, we don't stop. If n equals to 0, then you stop. So n minus step equals to 0. Then you return 1. Yeah. Okay, let's try this. Yeah, but there's no base case here. I think it should be n equals to 0, then return 1. N equals to 0, return 1. Yeah. Okay, so let's submit this. I don't think it's there should be some problems. It's taking forever. Okay, 38 and its runtime is exceeding. Okay, what did I do? I'm not sure if this is even a correct solution. We add. What other test cases do we have let's say 4. Yeah, it seems to work, but it's just that the recursions are really slow. Okay, that's not necessary. Alright, what's happening? Okay, I think we have spent enough time on these. Let's look at the solutions. Okay, it climbs this. And so this looks like Fibonacci. Yeah, this is simple, but I can do it. So if more than I, written I climbs this and 0. Okay, yeah. 1 to 5, 3 to 5, and so on. Recursive memorization. Yeah, this is Fibonacci. Dynamic programming. Could do that. Yeah, totally can do that. And I didn't. And there's also a case where I equals to n, and n I. What is the I here being referred to? I'm sorry about the notifications. Okay, I think I'm gonna pause the I'm gonna pause the live stream for a bit.